the name itself indicates, branch instructions means change the flow, the instructions which change the flow of execution, you can say, are the ones which change the flow of instructions. Please understand, flow of execution. You can say flow of execution. It means that I'm running a program. I'm running a program. In between, I wanted to go to some other subroutine, small program outside. Then go to that particular address, run the program in that particular memory, and come back to the original program. That is the main program. Okay, so in such situation, branch instructions are very much useful. Please understand, branching from main program to the other small program and coming back also will be taken care by these branch instructions. So you can indirectly say these are the branch instructions used to you can say used to call a routine. You can call it as a routine. If I wanted to call a routine or subroutine, okay, subroutine is a small program outside, so which can be executed and we can come back by bringing the processor to this particular main program. So branch instruction does that. This type of instructions allows the program to have subroutines. So it means that the programs can have, what are those things? Subroutines. Okay, subroutines, and they can have, what is that called as, if I want, I can put if then else statement. Okay, if then else structures I can bring in, if then else structures, and I can bring in loops also. So I can bring in loops. So what are the different types of branch instructions available? If you check out BL, so first is B. Let's say B is the branch instructions, so it is written as branch. Okay, so branch, when I say, very interesting point is the program counter will have the label. So the program counter will have the label. Label is nothing but the address. Branch to that particular address. That means the PC program counter has that label. That is how it is associated. When I write the instruction, you will come to know. So for example, BL. BL is another branch instruction. It is saying that branch with link. There is a small difference with branch and branch with link. Branch with link, before that, when I say branch looks into the PC. It means the address is stored in program counter, and what the LR will have. LR, if you remember, R13, R14, R15 are reserved for stack pointer, link register, if you remember, link register, and then you have program counter, that is R13, R14, R15. So R14, that is LR. LR is used here in this branch instruction. So what this LR will have? LR will have the address of the next instruction. Next instruction, you can say next instruction. Before that, sorry, I should not write here. That is only PC for branch. Now I should write for this, correct? Because PC will have here. So again, what is that? The PC will have the label. It means address. Okay. Then what extra thing with the link means? Link means it has link register that has the address of the next instruction after the BL, after the branch, after the BL. So LR will have the address of the next instruction. It means that it went to the subroutine there while executing the instructions in the subroutine. Subroutine is a small program. When the program, it means when the processor goes from main program to subroutine, in the subroutine, it has to execute instruction one by one. So to go to next instruction, what is the address? Where is the address? The address will be there in LR register. PC is different here. PC is having the address of the main program instructions. Now PC has just the label where to go. LR has the address of the next instruction after the BL. That is what the meaning. Now, if we put BX, BX is nothing but it is called as branch exchange. This can be used when I can use branch exchange. So here it means it has certain extra concept, branch exchange and branch exchange with list with link. Branch exchange and branch exchange with link are used are used effectively in certain applications where PC will have the address from a register. It means it is not directly having the address, a register RM, and it is having the offset. What is that? We will come to know. First, let us write 0xxFFFE. So I need to have 7FE. Okay, and it has T, which is equal to RM ANDed with 1. So this is very interesting concept, saying that branch exchange is very much used when I'm making use of instruction set from one instruction set to another instruction set. When I'm going away, it means when thumb instructions I wanted to make use, will come across branch exchange and branch exchange with link. So let us not worry much about branch exchange now. When we deal with the instruction set of thumb instructions, then we will talk more on exchange with what is that called as link. So branch exchange and branch exchange with link, you can observe here T is taken as 1. Why it is considered, and why the concept of just a minute. So why the concept of branch exchange and branch exchange with link are used? When I'm switching over from ARM instruction set to thumb instruction set, and I need to make use of these instructions. So again the same thing. So when it is said that link, the PC has to have the RM and it has to go along with this particular address. So let's have this. So and then the T will have the value. What is this T? The thumb bit in the CPSR, if you remember, it has RM ANDed with 1. So why to do with this? And also along with this, since it is a branch exchange, this is what required. Branch exchange with link means in the subroutine, I mean when I'm there in the instructions with the thumb, then I need to make use of those instructions one by one execution. So the address of the instructions, the next instructions will be stored in the link register. So address of the next instruction after BLX, that's the meaning. So BLX, you can say, sorry, it is the above one is BX and the second one is BLX. So that's the thing. So these are the 4 branch instructions. Now only 2 branch instructions we'll talk about. Let's say branch PC label. So with that particular address, it will jump to that particular address. That's it. BL, if you take branch with the link with the PC label, it means PC address. Then when it goes out, there the instructions are executed by incrementing LR, and also coming back the address will be stored. So for example, it has been shown here, just say. So let's say, for example, uh, we will take here we are not going to discuss something about pre and post, because it's a jump instruction. We cannot make use of pre and post. So there is a concept called as forward and backward branching. You can name it as forward and backward branching. It means when I use B, so let me write here, when I use B, so when I use B, it's a branch. So what is the word I'll use? Forward. The, the word I'll use is forward. So when I use forward, I'll use the instruction add. So let's say add. Some instructions are not comma, R2, comma, let's say some #4. It means that I'll add 4 with R2 and the result is stored in R0. So this is the flow. Let's say a program is there, the main program I have written, something, whatever it might be. So I'll say R1, any data. So let's say some 25, whatever it is, some data I moved. So like this, I can write any set of instructions like this. So only thing is how this B forward means that forward is the label. So that label I should write this side. So you can just say, so like this. So that's the add instruction. So like this, the main program is written with so many instructions. After the so many instructions, now I have to make use of what is that called as forward. So I'll say forward label. So it means the the operation, it means I'm just jumping by skipping those instructions. Forward means I'm skipping to that particular label. So PC will have address. That forward is the label. That label is nothing but address. That address will be there with the PC. So branch forward, when I say branch, PC will immediately go to forward. Forward address is there with PC. So it skips all these instructions and immediately the processor cursor comes to the forward. So it runs the particular instruction which is written there. So it means it jumps to that particular address where the instruction present here is R1 comma subtract R1 comma R2 something hash some to whatever it is data. I have some more instructions. So it executes like this. This is what is that called as just forward. So now when I say forward, you can understand it means that simply going further. So when I say backward as an example, so that backward represents you just write, I'll say backward. Now when I say backward, now you try to understand backward is the label here. I'll write it as a label colon if you want. So when I write this, so if you cross check what is the instruction written. I have so many instructions, let's say. So add instruction is there. Okay. So let's say R0 comma R1. Okay. Whatever instructions comma hash 8, some instructions I am writing. Okay, so let's say I have written some add. Okay, so let's say R2 comma uh, some hash to whatever instruction. I'm just not writing the specific instructions. R1 whatever I can write and some hash 2. So like this, some instructions I'm writing. Why I'm writing this? So I'm just putting a branch instruction here saying I am jumping to backward. So what it indicates? If you understand both the difference, for the first one forward I wrote, that is the one which skips the instruction. Okay, it is jumping to the particular routine, you can say. Now here in backward, when you see the branch, when I'm using, when I say backward, this is referred as a loop. That's what you see. When I say backward, again all these instructions are executed, again backward all these instructions are executed. How many times? Unless I put a condition to come out. So this is called loop. That's what the branch instructions are, only for changing the flow of execution. You can say these programs can have subroutines. They can have subroutines or if they'll structures or loops. So like this, these instructions, how to utilize them in writing a program. Some of the programs we'll see. These are the ARM instructions. So practice, as I said, all the data processing instructions discussed earlier with pre and post. Write your own instruction, write your own value, take 32-bit with different 32 bits, check for all flag bits after performing the operations with the data processing instructions, and similarly check with multiply instructions, then check with arithmetic, compare instructions, do all the stuffs. That is a practice. So pre and post. Then you work with branch instructions, writing some program saying that I am branching to some routine. Then backward instruction saying that I am putting it under a loop. Likewise. So remaining two instructions like branch exchange and branch exchange with link, we'll come to know the details of them in thumb instructions. When we deal with thumb instructions, how these can be utilized. So this is all about the instructions, load and store instruction, and the program status instructions in brief, all those stuffs. Load and store in instructions in detail we'll study in the next class. Okay. Today I will talk something about the one more program with the fourth unit. Means I need to discuss some concept of fourth unit now. We'll talk on now DC motor. So you know DC motor, right? So that is what we will discuss now, and we will see the result, and I want you to execute it and realize the output. So DC motor and stepper motor, I'll ensure that today and maybe in the next class I'll complete it. you execute yourself using your Keel software as well as your Proteus, then get me the results. So again, I'll put it as one more assignment. Okay. Now let us see now. I'll just stop sharing this and I'll go to the other part of it. So before that, instead of saying, I'll just go here now. So if I'm not audible properly or any problems, you put it under chat so that I can see it. Okay, I can see it. Otherwise, if no problem, just say no issue. Just type, any one of you type no issue. Okay, so fine, thank you. Now let's go ahead. What is that? So let's check this now. So where I am, let me check this. Okay, so something I have drawn here. I think it is visible. So now I need to write a program. Write write a program to run a DC motor, to run, instead of saying to rotate a DC motor, okay, DC motor, DC motor clockwise and anti-clockwise. So you know these things, anti-clockwise. So okay, so just nothing to worry much. What is that? Clockwise. Okay, you can find so many things about DC motor, nothing to worry much. Simple DC motor is there. So DC motor is another external device which can be controlled using your ARM processor. DC motors can be used in many applications, as you can see, even from smaller applications to bigger applications, where I wanted to just open a door, close a door, or open the garage, or something like this, the higher end. And at the lower end, you, for many applications in your projects, you are using a smaller DC motors. Now the interesting point is, I need to have the driver IC for this. So we need to perform this hardware experiment in the lab. When you come back, as I said, all the 6 to 7 experiments, we will do hardware experiments again in the lab. Before that, realizing those hardware here itself we can do, that is using Proteus software, I said. Now here it's not much what is that called, effective. By using Proteus software, I can realize completely the effects of all the driver ICs and the associated processor effects, but we can visualize how exactly the things are happening with the hardware using Proteus software. Now the DC motor makes use of L293D, okay, driver IC. Please remember this driver IC. So this is the driver IC which is of 12 volts, okay, which drives the DC motor, that's it, drives the DC motor. So now, so what is that, if you observe, L293D IC has total 8 transistor configuration as shown in the diagram. You can see two different configurations of this type. What is shown in the diagram, two different configurations will be there. So it's a package of two, you can say. Okay, so now some these two will be there. So now it means that this particular L293D driver IC can run two motors, but we are showing here only one motor, and the pins used for this are port 0 pins, port 030 and port 031. Simple working principle. The details of this particular thing, how exactly it has two configurations and how many pins that L293D has, and how it is interfaced with the microcontroller ARM processor, how it is interfaced, those stuffs in hardware block we can see when you come back to lab. Now, as of now, it's a very simple explanation. As we said, a motor I have shown in the diagram. There are 4 transistors, Q1, Q2, Q3, Q4, which are there, okay, in your driver IC. Now you can see the input, let's say P0.30. So as I said, P30.30 means if I call it as output pin, so I need to declare IODIR, that's it. Which pins I declared as IODIR here? 0.30 and 0.31. Declare them as IODIR and then connect like this. What is that? P 0.30 goes to transistor Q1 and Q4. You observe. Input, it means whatever comes on the output pin P 0.30, it goes to these two transistors. If one comes, logic 1 comes, transistor Q1 and Q4 are on. Very simple. So the motor has to rotate in a clockwise direction, and based on how much delay will give, that much delay it will take and how many rotations. So you can see that. And if I give the input logic 1 to the P 0.31, Q2 and Q3 are on. Okay, so once it is on, it rotates in anti-clockwise direction. The meaning is around 600 milliamps of current flows through this in a loop. So current, how it flows, based on that the direction of the particular motor moment is understood. Very simple. Clockwise, it rotates when the current flows. On means what? There is a connectivity. Q1 off means no connectivity. Q1 and Q4 are on means you can see the cycle. It will be clockwise loop. It will be a clockwise loop. The current flows through the motor and the loop completes and it will be clockwise. Now when it reverses, it means that when 0.31 is made high, instead of 30, Q2 and Q3 are turned on and the motor rotates in other direction. So clockwise and anti-clockwise can be done by just utilizing the pins P3.0 and 3.1. Sorry, 0.31. 0.30 and 0.31 are used. Now, how to supply the values to this? A simple way of writing a program. You know the concept of making use of pin select register and making use of IODIR, making use of IO set and IO clear. And you know how to write the delay. That's it. The simple program. Now we'll realize this program and more details of L293D and how exactly the rotations can be controlled, how the speed can be controlled, all those stuffs we cannot show here. Those things we'll realize in hardware. So that is the simple analysis of DC motor. Now how to write a program? I'll just share it now and I'll come to the coding part of it. Before that, I'll just go to the what is that called as your Keel. Okay, so I just opened the Keel software. Okay, so let me write. Okay, so let us write a program. So how do you write a program? Now you just start writing a program. What is that? I'll just name I'll write here what is the DC. I have already written, but still I want to write in I want to write with you so that it becomes easy for you. You know how to write a program. Hash include. Okay, so you need to write LPC. You know that 2148. 48 instead of write X I should write, right? Any family series 41. Okay, so now this is the thing. Now what else we need? So I'll say wide delay. I need a delay code, right? So I'll write wide. Okay, so I'll make use of this. Now two things, two functions I'll call. Delay function I called. Now I'll call DC motor. I'll say clockwise. Okay, I'll say clockwise. So clock means clockwise, I'll understand. So clockwise. So I will use one more function which is called a simple. What is that? So nothing to worry. If anything wrong we do, so it will throw us an error. So you just try to write the program on yourself without seeing anything. If something I do wrong, I'll again rectify myself by checking the errors. So now how do I start? I declared all the three functions like this. I'll start int main. So what is the main program should have? Which pin cell I should use? Since I wanted to use P0.30 and P0.31, I should use pin cell register 1, 0 and 1. 0 is from 0 to 15, 1 to 15, you know. So 16 to 31, we have pin cell 1. So port 0 needs two registers, pin cell registers. So pin cell 1 I'll use. So pin cell 1 is equal to 0x. So 0, 0, 0. I'll declare initially 0 0. So 8 zeros, that's it. So next pencil, once it is done, I need to select IODIR, correct? IODIR 0, it is associated with 0. Now which value I should feed this? I will use pin 3.0, pin P 0.30, P 0.31. Last two pins should be high. For that, can I write like this? C. So I'll write C 0 0 0 0 0 0 0. C means 1 1 0 0, remaining all zeros. So I kept C is 1100, remaining all 4 zeros. If you write all total 32 bits, last two bits 30 and 31 are high. That's what I kept C. Why C means that is what IODIR, I declared them as IO. So now I wrote 4 bits, that's it. Now, so what is the program? As usual, I'll go with while true. Okay, I'll enter the loop. So what is that? I'll jump to the clockwise direction. I want this to happen. Then I'll jump to what? I'll have a delay in between. So I'll put a delay. So you can see a delay. So I'll say next, same thing. What is that? I'll use the function. Okay, after clockwise, I'll come back to anti-clockwise. It means I wanted to rotate both direction and see the result. So that's the delay simply. So I'll just close this. So my main program is done, you can say. So what I need to write now, I need to write the functions. So which are the functions I called? I said void dc underscore clock. So I just wrote like this, and in this what I should write now. So clockwise, as we said, now interesting point, I need to do the IO set and IO clear. So IO set 0, right? IO set 0 I should use. IODIR 0, IO set 0. So IO set 0. Now, which value I should keep it here clockwise? Whether I should keep, when I say clockwise, what value I should keep? If I want clockwise, so I will put first, it means I want 31 should be high. So 31 means 8 I'll use. 30 I don't want. So I'll use 8. So 8 means 100, remaining all zeros. So total 7 zeros followed with 7 zeros, correct? So 80. That's it. So then what I should call here? The same thing, delay. Then after IO set, IO clear, IOCLR 0, correct? So the same way you just realize the program. So what I should say, 8 followed by 7 zeros. So it means that now I am trying to give the value to pin 3, pin P0.31, not P0.30, only P0.31. When I give P0.31, you understood Q1 and Q4 will be turned on. That's the meaning. So once Q1 and Q4 are turned on, the motor will rotate in clockwise direction. So please understand. The flow of current, that is 600 milliamps, will be in that direction. You can understand. So the second thing is, I'll close this and I'll write void DC for anti-clockwise. What is that? Anti-clockwise function. I will write the code for this. What is that? The same thing, right? I'll just copy this. So the same, nothing to change. So Control C, and I'll say Control V. So what is that? I just forgot to mention the semicolons. Put the semicolon, and what the value I should give now? P 0.30, I wanted to make it high. 30 means the value should be not 31 bit, it's a 30th bit. It means I'll put it as 4. 4 means 0100. So 0100 means it is pointing to the P 0.30. Please understand. That's it. So one time 8 I given, one time 4 I have given. That's it. So when I give this, my clock and anti-clock, please see anti-clock I have given. That's what I write. I should write the function same, anti-clock only. E anti-clock. Now, as usual, what next? I should write wide delay. So wide delay. So what's the code for this? You know, I'll declare int I comma j. We know this. And for what is that? for I is equal to 0, I less than let's say 1000, okay, and I plus plus, so some delay. So for what is that, j is equal to 0, j less than 1000, correct, j less than 1000, something like this, you know that, j plus plus. So I'll end up the semicolon. Please remember where to put semicolon, all those steps. Once you write on your own and practice, you will become perfect. So try to have the habit of writing codes. That will help you for interview purpose also, and writing any sort of code. Okay, teachers might not be excellent in that. You will become very much excellent if you practice more and more. So now, so with this, if you check now, so what is that? So this is the code, okay, for 1 second, for clockwise and anti-clockwise. So you can cross check. So now I will save this file. So file save as, okay, so file save as. So I will save this file as dcmtr that's .c dc motor dcmtr.c, because this code I have. So this already I have what I have written. I'll just remove this file. Now you check what is that. I need to add now source group. I need to add this first. You know that source group, right click, add to the source, dc motor.c, add, correct. So this has been added. Now double click on this, then run this. I mean, compile this, compiling first. If any errors are there, any mistakes I have done, it will show me error. One error it came. What is that error? Let me check. So that error is last line. So for j is equal to 0, j is missing here in the loop. That's what it is telling. So you check here in the delay code. What is that mistake? You just identify like this. You just rectify yourself by writing on your own. So then save. I'll say save. Then again I'll say translate, compiling, and then I'll say build. So now no errors, compiling, so zero warnings, not an issue, creating hex file. Now what is that hex file it is created? DCM is the name of the hex file. Why it has taken DCM? Because once I compile this, because we have already set, where is that target? Go to the target left side, there is one icon. What is that? Target options. Click on target options. You see here, where is that? First you check on target, 12 megahertz I set already. I have said, that's what, no need to change anything. I'll go to output, click on output. I already set that debug information selected, create hex file is created, nothing to worry. Name of the text file I have given DCM here. So if you don't want, you change the name dcmtr. If I want to call, you call dcmtr.hex file will be created. So I'll say okay. Once I do that, in where I did that, please remember where I did that, in the output I just changed that. Even I can check linker, no need to check again and again. Linker should be use memory layout for the target dialog. This should be there. So then only thing is output is very important for us. I need to select the hex file which is selected, create hex file, then say okay. So once you do that, again run this, compile this. Now you can observe here, creating hex file. Hex file name is dcmtr now. So that's what we should understand. So dcmtr hex file is created. Now I will switch over. This is the program perfectly working. So now I'll switch over. What is that? I'll just stop sharing. Now I'll go to Proteus now. Where is the Proteus? I'll go to the Proteus. You keep the Proteus open. So now then I'll open the file. So file open. So some recent file I'll open, because I can't do it now from the scratch. I will show you. So simple DC motor. You please understand. Once it opens, I'll show you that. Just a minute, it's taking some time to open. You can create your own this thing project, Proteus design, new project, go to new project, do the same stuff what you have done for LED blinking, and one more is your what is that, 7 segment display, the same set, you just do it, and creating the, what is that called as mm, your components, I mean bringing all the components, putting it there, and the default left side coding, default left side components connection I already told. Only the right side, what is that application you need, should be checked, right? So this is the Proteus. Is it visible in chart? Quickly, can anyone? Yes. Now you please check this. What is the simple way? I'll just let you know. See this. What is that? You observe the first part, left side. You know how to and connect them to ground. This must be, and ensure that the crystal what you have chosen, when I double click on that, you should ensure that it is 12 megahertz, the value you have set. Okay. Then take a register. That's what you see the component side here. What is that? 7 segment digital, 7 segment. I mean, uh, this 7 segment I have taken for connecting to this. Now I removed that. That is not there. So battery, cell, ceramic capacitor, crystal, all these are common. Even I LED red, I removed it from this diagram. The component I have selected, that's what it is visible. Motor. Now which motor? Only extra is motor I have connected. So remaining thing, battery I have taken cell, I set the value as 3.3. So positive is connected to all VREFs and negative is connected to VSS, all VSS. So that's it. No, nothing grounding. It itself is a ground. Then there is a switch for resetting, and that switch I have connected to the ground. These three parts are common to all the experiment. Nothing to worry. Same way you practice once or twice. Only thing you can observe is extra motor I have taken, DC motor. That's it. Where I have connected DC motor, you cross check now. So if I check this now, so if I check this DC motor, I am just maximizing for you to visualize. I have taken a DC motor. How I have taken DC motor? I went to P. I clicked there. Please understand. I clicked there P. Okay. P is the where I need to search the component. Okay. Motor. Simply DC motor type. I have many motors. You can see here electromechanical, mechanical, I mean, all categories. And in that, I'll choose any one of these motor, simple DC motor model or active motor model. If I click here, you can see here simple DC motor I have chosen, and I can take this motor also, active motor. You take any one of this. So say okay, then it will come there. But I have already taken, so I'll just cancel it. I have taken and kept here. So what I did, I just see. So let's say I'll choose this. Okay, just a minute. Give me a second. Just a minute. Just a minute. It is taking the connection. Where is the select? So I'll delete this. I'll delete all these things. You see, simple connections. I have taken the motor. So what I should do? I should select this and bring and connect it to 30. You can see here 30 pin number 30 P 0.30. And the below 1 point, I'll just take it and I'll just connect it to P 0.31. That's it. So now what I should do? I have connected this. I need to set the configuration file. Double click on this or a single click. It is left to you. Now you observe LPC 2138 we have used. Okay, so you just observe DC motor dcm.hex is there 12 megahertz, but our hex file is different. So I'll go there and hex file. So DCMTR we have taken. DCMTR is our file now. DCMTR hex I'll open. That's it. So 12 megahertz I ensured. Please ensure 12 megahertz. Then say OK. That's it. Very simple operation. This is a simple execution of DC motor. This DC motor will make use of L293D driver IC, but here it will not be shown because it's not an actual hardware. So realization is very simple. DC motor can be easily interfaced with the ARM processor and the results can be visualized. Now I should run this. Where is that? At the lower side, run the simulation. So when I run, it will take some time. You can observe the color of the DC motor. It changes to blue and it has to rotate according to our wish. Now you see. So one side, another side. So only once it rotates. Okay, once it rotates. If I wanted 4 steps to be rotated, then I need to put under loop. You cross check. What is that? DC underscore clock, DC underscore anti-clock. You can make it to rotate 4 times anti-clock. It means 4 clock, 4 steps. Try that. So observe it's rotating. Correct? Clockwise once, anti-clockwise once. You can cross check. You can interchange and see how exactly it happens. And if I, for example, if I give the delay, if I increase the delay, let's assume I'll stop here, stop this, and I will give the delay in my program, which I'm not showing it to you. What is that? In Keel, I'll just make it instead of 1000, I make it 3000, let's say. Large delay if I give, I will just save it, then I'll translate, I will just build it, it's linking, and I'll say rebuild it, it's creating me the DC motor hex file. Then again I'm coming back to this what I'm showing, which is Proteus. Double click on this, I'll choose again the updated version, which is DC motor hex. So DC motor hex I'll choose, I'll say open, and then I'll say OK. So once I did that, I'll come and say run. So I'll wait for it and I'll see how much rotation you can observe. 1, 2, 3. So I correct 5. Just observe how many times it goes. It stopped now. Now rotation this side. So it means if I change the delay, it has to rotate accordingly. It's taking too much time and it's got stuck here. Okay. So that's it. I just made it 3000, 3000. So 3000 cost 3000. That's what you see now. It's rotating in other direction. Okay. So you visualize the output, I think. Anyone chart? Have you visualized the results now? Okay. So please practice. Please practice. This is what important. In the next class, I'll come up with your load and store instruction set of ARM. Once we complete all instructions, we'll be capable to write any sort of program. Those kind of some programs we'll practice with ARM processor also, along with IO programming. So this is a part of IO programming. In the next class, I'll bring up with load and store instructions. We'll do that also. Along with, we'll work out the next experiment, which is stepper motor. So all of you practice today the DC motor on your own, connecting all the components, realizing the code, writing the code yourself, and becoming more perfect to writing the code and executing it perfectly. Okay, so you can build your own code with the different set of instructions also, with IO dir, IO set, IO clear, and IO pin also can be used. See, some people will write the logic with IO pin also. That is also possible. So please think in different directions and practice. Okay, so I'll stop here. In the next class, we will see the stepper motor program, and before that, we'll try to do the load and store instructions of the ARM instruction set. Once we complete load and store instructions and program status instructions and software interrupt instructions, that unit will be complete. And here the stepper motor, LCD configuration, and keyboard experiment if we perform, and then we'll be doing another two experiment with ADC and DAC. That completes the fourth unit. Likewise, so we'll go in steps so that you also practice with me and you are going to submit the assignments accordingly. Please ensure that you are submitting the assignments. I am not forcing you. Those who submitted, I will realize that they did it. Those who haven't submitted, I'll ensure that they haven't done it. No excuses, please. Okay, you ensure somehow you are making use of any desk of others, or you are taking help from your friend, or taking the laptop from your friend or relative, installing it, working with it. If you're finding difficulty, speak to your friends, install it, speak to me, install it, and work it out. Still you are not installed, if you put a word, it doesn't help. Once 60% of the students are nicely able to do, means why not the remaining 30? And one or two exceptional case where they are in very much remote place and they don't have laptop or don't have computational capability, they can be excused provided with the 100% perfect reasons. Okay, so unnecessarily don't put the reasons, because you are the losers, nothing can be done. So try to have in this pandemic situation the great effort to do something more. Okay, so I'll stop here. We'll see the rest of the things in the next class.